Yes. 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 Beautiful. We put units on the pascals if you want credit for it. That's right. That's right. They're both right. You got it, Jasmine. Okay, I did a funny thing this morning. I needed to deliver something to Byram Elementary School.
What do you need to deliver?
A packet of stuff for like the union rep there.
Okay.
Now, are you picturing this?
Yeah.
I pull into Byram. And you go in there, you take a right and then or wherever, you know, and you pull in there. And what I did was I parked outside of the school grounds. I didn't actually pull into the parking lot and park. I parked like in the neighborhood right outside the school, ran all the way to the school, dropped the stuff off, ran all the way back to my car. Why did I do that?
I don't know. Because the parking lot was getting really cool quickly.
No. Because once you get in there, right, how do you have to go out? You're supposed to go out the other side. And even if there's nobody around, I hate going like against an arrow like that, right? I've got this crazy lawful good sort of thing, you know, like I want to obey, right? So if you go out the other side, I've never really known where I was. There seems to be no connection between that side of Byram. It's like a totally different world, another universe, right? In fact, the last time I went to Byram, I went out the other side and I just wandered for like what seemed like hours until I saw a sign that said Martinazzi. I'm like, okay, I recognize that word. I will follow it one way and it will lead me to some place that I know. And I ended up at a strip mall. And I was, yes. Is there like an easy way to get back to Boone's Ferry? Can you just take every left? Every right? Oh my God! I like more than one left turn.
You drive up the gravel path
and go through the school. Just walk over there. Yeah. That occurred to me too, but I figured that was even wronger. Yeah. And like going against the.
You can go out the other way.
I know. Oh, you mean like go the wrong way?
It's not the wrong way though, as long as you go out the roundabout. Because how does it?
No. They've got it now marked, so you're supposed to only go in that one direction.
But then how do the people who live there get out of there? Like, you know, the street that goes up to Byram, how do they get out?
Well, the street is not one way, so I parked on that street. Yeah. But the vortex, basically the Schwarzschild radius of that thing is right there. You know, the what is it? The event horizon of Byram is right there at their like. Where you go in, there's a speed bump, right? And then you can't get back, right?
Reverse your car.
Yeah, not legally.
All the way back.
You can violate conservation of energy and go back out. Are we ready for the next one?
Yes. Yes.
Yes, no. Yes, no means no.
No, yes means yes.
This is what I did. I added 14.7 and got 49.7, right? Divide by that, multiply by that. Yeah. Take a planner. Yeah. Tuck that under your arm. That's an atmosphere in pascals. That's an atmosphere in pascals. So this is, the thing in the parentheses is just atmospheres, right? And if you multiply atmospheres by that, you get pascals. Yeah? Are we good? We deeply need to move on. Oh. If you have an absolute pressure of 812 torrs, What is the gauge pressure? I just want the answer in torr. I want you to have said after you're done with that problem, I really tore through that problem. How do you go from absolute to gauge? Just absolute minus an atmosphere, right? That's right.
There's only so much.
Yes. Yes. Yeah, you got it. Yeah. Question. Why do they say torr instead of millimeters of mercury? The answer to that is, anybody know the answer to that? The answer is,
Black magic.
I don't know. I don't know. I was hoping somebody like helped me out there, but that didn't happen.
It's kind of like, why is 1 pound officially a pint?
So I'm going to write this here that absolute pressure is gauge pressure plus 1 atmosphere, right? That goes in our little box of secrets, yeah? And then finally, there's nothing to do but no, we don't need to do that. There's nothing left to do but, and ideally, ideally, we'll get to a point where you can actually try one of these problems, okay? So this is these problems on the sheet. Class, can we focus? Good luck. Casa de Pepe. He's got to do his little internal, thing.
House,
Pepe's house, yeah, I think. Pepe's just some dude. It's Pepe's house. Just get over it. All right, so. All right. Let's get this out here because I spent like a lot of money on this. I think this costs like $100 or $200. This little jiggly thing with the jiggly. I know. Here it is. Let's turn that thing up there, right? Okay. Now, concept 0 is that pressure literally means the amount of force that it's exerting on the walls, right? And if we think about a gas, and we're quiet about it, right? If we think about a gas, the force that's exerted on the walls is the aggregate force that all of those little mini collisions are exerting. Now with this thing, the collisions are not happening very often and are spread out all over it. But in a real container, you're going to have gases with disparate velocities just like that, right? But you're going to have like 6.02 times 10 to the 23rd atoms running into the walls. Are you going to necessarily feel each individual collision? No, not so much. They're hitting you right now, and some of them are going 4,000 miles per hour. And gee, it's like, oh, geez, I hate that, right? Okay, but it still does things like it dries water up and all this stuff, right? So it's not that it does nothing, right? But it's just that we're used to it, right? Now, let's think about pressure and how you could increase that pressure. What if I put more stuff in there? Would that increase or decrease the pressure? More stuff makes it bigger. So look over there. See the P equals nRT? Stuff is N. That's number of moles. If N gets bigger, doesn't P get bigger? Yeah. That makes sense. Doesn't that make sense? I'm trying to make PV equals nRT something that you understand, not necessarily just something we plug numbers into blindly. Okay? So N is the amount of stuff. R is just a constant. Ignore R. Okay? How about T? What is T in the case of those little things jiggling around there? It's the temperature, right? So what does hot look like compared to cold? Hot is fast, cold is slow. Why does temperature increase the pressure? The hotter it is, the faster they're going, yeah. The higher the temperature, right? So that's why temperature increases pressure, right?